Some numbers just blend in. They're part of the background noise of our lives. But every once in a while, you stumble across one that looks totally normal, but is hiding some absolutely incredible secrets. Today, we're going to crack the code on one of those very numbers. 153. Yeah, just look at it for a second. Doesn't seem like much, right? Kind of plain. But what if I told you this number has so many bizarre, unlikely properties that mathematicians have been geeking out over it for centuries? Seriously, what on earth could be so special about 153? Okay, let's get right into it. To really get what's going on here, we have to start unpacking what makes this number tick. We're going to start with the weird stuff, the strange properties that make 153 a true mathematical marvel. All right, first up, 153 is what's called a narcissistic number, and honestly, that name is just perfect. It means the number is, well, kind of in love with itself. Here's how it works. You take each of its digits, that's 1, 5, and 3, and you raise each one to the power of 3, because they're 3 digits. Then you add them up. So 1 cubed plus 5 cubed plus 3 cubed. What do you get? You get 153, the number itself. That's just wild and incredibly rare.
But wait, it gets weirder. The coincidences do not stop there. 153 is also the sum of the factorials of the first 5 whole numbers. Now, a factorial, with the exclamation point, just means you multiply a number by every whole number smaller than it. So we're talking 1 factorial plus 2 factorial plus 3, 4, and 5 factorial. Add all that up, and yep, you guessed it. You land right back on 153. I mean, for a number to have both of these super specific, kind of random-seeming properties, it's almost unbelievable.
So let's recap. We have a narcissistic number that's also a factorial sum. I mean, that alone would make it pretty special, right? But believe it or not, these are just the first couple of clues. The trail is getting deeper, and the list of oddities just keeps on growing. Okay, get ready for this. The properties just keep piling on. It's the sum of alternating squares all the way up to 17. The sum of its digits, that's 9, which is 3 squared. The sum of all its divisors, that's 81, which is 9 squared. It feels like this endless rabbit hole of cool facts. But hang on, look at that last one. It's the 17th triangular number. Now that sounds different, doesn't it? It's not just some quirky calculation. It sounds like it's part of something bigger. So that's the big question, isn't it? All those other properties are fascinating, for sure, but they kind of feel like random trivia you'd pull out at a party. This triangular number thing, though, that feels like it could be the key to the whole mystery. So what exactly is a triangular number? And where do they even come from? Answering this is going to take us from one weird little number to a truly grand and beautiful mathematical structure. See, the answer isn't something you can find with just a simple calculator. Nope. It's hiding inside a pyramid of patterns, a famous mathematical structure that holds countless secrets in its surprisingly simple, elegant design.
And here it is. This is where our answer has been hiding all along, inside Pascal's triangle. Now, I know it might look a little complicated, but it's built on a rule so simple you could teach it to a kid in about 10 seconds. You just add the 2 numbers directly above to get the number below. That's it. And from that one single beautiful rule, an entire universe of mathematical patterns just emerges.
Yeah, hidden inside the diagonals of this thing are some of the most fundamental, most important number sequences that exist. It's like a code book for how mathematics itself is built. Let's take a look. If you go down the first diagonal on the edge, it's just ones. Okay, kind of boring. But now look at the next diagonal in. What do you see? 1, 2, 3, 4, 5. Yep, the natural numbers, the counting numbers, the very first numbers we ever learn are just sitting right there waiting to be found. Okay, so what about the next diagonal? Let's trace it down together. We've got 1, 3, 6, 10, 15, 21. Ring any bells? These are the triangular numbers. We found them. We found the home, the family that our mystery number belongs to. All right, we have all the pieces now. We've got our weird, self-loving number on one side, and we've found this fundamental sequence where it lives on the other. It's time to connect the dots and finally solve this thing. So what does it actually mean to be a triangular number? Well, it's really just the sum of all the whole numbers up to a certain point. The first one is just 1. The second one is 1 plus 2, which is 3. The third one, 1 plus 2 plus 3, which is 6. You see the pattern?
So, if you keep this going, if you add up every single number from 1 all the way up to 17, what do you get? You land on exactly 153.
And that is the big aha moment. See, 153 isn't just some random curiosity. It's not a mathematical freak of nature. It's a predictable, orderly member of one of the most fundamental sequences in all of math. It has a place. It belongs.
So what's the big takeaway from all this? I mean, it's not really just about one number, is it? It's about that profound, deeply satisfying feeling of finding hidden order where you thought there was only chaos. This really gets to the heart of it all. In mathematics, things that look strange or just coincidental are often part of a much deeper, hidden order. We started with a number that seemed like a collection of bizarre party tricks, right? But by following the clues, we found out it's actually part of this grand, elegant, perfectly logical system. And that journey, from mystery to understanding, that's what makes math so incredibly beautiful. And hey, just to show you how deep these patterns really go, here's one last little surprise for you. If you reverse the digits of 153, you get 351. And what do you know? 351 is also a triangular number. It's the 26th one. How cool is that? Just a perfect little piece of hidden symmetry.
It really makes you wonder, doesn't it? If a simple, ordinary-looking number like 153 can hold so many layers of hidden structure and beauty, what other secrets are hiding in plain sight, in the numbers all around us that we see every single day? What other patterns are out there, just waiting for us to find them?